to my video on frequency distributions. So a frequency distribution shows how often an item, a number, or interval of numbers occurs, and it can also be referred to as a range. Now, this doesn't mean range, bigger number minus smaller number. It just means a range of numbers, an interval of numbers. So these are intervals right here, 31 to 35, 36 to 40. A frequency distribution can be used to construct a histogram. And histogram is like a bar graph, and we will learn that in a future lesson. So the directions here say circle the largest and smallest value and then choose the most appropriate class interval for the frequency distribution. Well, I've already made the intervals for you, okay? But if I hadn't, then we would use the smallest and the largest to help us do that. So the smallest is 31 and the largest is 54. So what we want to do is this interval is 31 to 35, so I have to count all the numbers between 31 and 35 and tell the frequency. So as I go through, I'm going to go through 1, 2, nothing, 3, 4, and 5. So there are 5 numbers between 31 and 35. So I cross those out. Now I'm going to look for 36 to 40, so I'm going to go through, and anytime I see a number between 36 and 40, I'm going to cross it out. So 1, 2, 3, 4, 5, 6, 7, 8. So the frequency is 8. That's just how often it's occurring. Now 41 to 45, 1, nothing, 2, 3, 4, 5, 6, 7, 8. So the frequency is 8. And now 46 to 50, I go through 1, 2, and nothing. So the frequency is 2. And then remember, this is circled. I haven't crossed it out yet. 51 to 55, there's 1 and 2. Okay, now notice if I add this up, it should equal how many are here, and this is 5 by 5, so there's 25 here. So 5 plus 8 is 13, plus 8 is 21, plus 2 is 23, plus 2 is 25. So there were 25 test results here. Okay, so how many students scored a 41 or higher on the test? I can look here. This is 41 or higher right here. This interval is 41 or higher, and this one is 41 or higher. So 8 plus 2 plus 2 is 12. So 12 students. How many students are in the 51 to 55 interval or range? So 51 to 55, I see 2 students. Okay, number 3, which interval range has the most number of scores in it? So look, I have 5, 8, 8, 2, and 2. It's these two right here. So I'm going to write 36 to 40 and 41 to 45. Okay, now we're going to look at the chart, and then I'm going to move it down so I can show you what percent of students scored a 46 or better. So if you look here, 46 or better is going to be this interval, and this one is also 46 or better. So 2 plus 2 is 4. So it's 4 out of what? Good. There were 25 test scores. So for the percent, we're going to write 4 out of 25. Now I know what you're thinking. I can just divide this, change to a decimal, and then change to a percent. Yes, you can do it that way, and you're more than welcome to do it that way on your classwork. But I'm going to show you using a percent proportion because percent proportion can be used anytime you have a percent or are looking for a percent. So we're going to review that concept. So if I have 4 out of 25, I have part over whole equals percent over 100. I don't know the percent, so I'm going to put it over 100 because percent's always out of 100. So remember to solve a proportion. 25 times x is 25x. And 4 times 100 is 400. Now the opposite of multiplication is division, so we're going to divide by 25. 25 divided by 25 is a 1 in disguise. And 400 divided by 25 is 16%. So again, the way most of you are familiar with is to divide this and get 0.16 and then change 0.16 to a percent. That's another way or strategy to get a percent from a fraction. Excuse me. Okay, let's go on to the second page, and we're going to talk about and review stem and leaf plots. So a stem and leaf plot is used for discrete numerical data and is used to show frequency of data distribution. The stem represents the tens place, and the leaf represents the ones place. So the data below shows how many raffle tickets FCCLA members sold. Use the stem and leaf plot to create a cumulative frequency distribution. So here are the raffle tickets sold, and we're going to use the key to help us read the stem and leaf plot. So the key says 5/1 equals 51. So remember we said the stem is the tens place and the leaf is the ones place. So this is read 40. This number right here is 51, 55, 66, 66, 66, 68, 69, 72, 73, 73, 77, 80, 82, and finally 84. Okay, so what we're going to do is we're going to look for all the numbers between 40 and 49, and we're going to put the frequency, and then we're going to do the cumulative frequency. So 40 to 49, I only see 40, so I'm going to put a frequency of 1. And cumulative frequency means all together. So after the first interval, what's my frequency? 1. Now, 50 to 59. 51, 55, and that's it. So the frequency is 2. And now my cumulative frequency is this frequency and this frequency together. So what's 1 plus 2? 3. So far, my cumulative frequency is 3, because all together so far I have 3 students who sold this amount of raffle tickets. Okay, 60 to 69, 1, 2, 3, 4, 5. So the frequency is 5. Now the cumulative frequency of all the students would be 8. If it was 3 here and the frequency is 5, I now have a cumulative of 8 altogether. 70 to 79, 1, 2, 3, 4. And now cumulative altogether, I had 8. 4 more is 12. And now 80 to 89, 1, 2, 3. So my cumulative frequency, 12 and 3 is 15. And the cumulative frequency should tell you how many numbers are in the stem and leaf plot. So yes, there are 15 if I count all of these up. Now we're going to answer questions below and state whether you use the stem and leaf plot or the frequency distribution table to determine the solution. So some of them are both, some of them we can only use one. So how many students sold? Exactly 73 students. Okay, so here we can tell 1, 2, so 2 students. And can we tell from the frequency distribution that 2 students sold 73 tickets? No. All I know is from 70 to 79, 4 students sold that many tickets. So we would write stem SNL plot, stem and leaf plot. Okay, how many students sold at least 80 tickets? So that means at least means 80 or more. So we can count here, 1, 2, 3. We can also look here, 80 to 89 would tell us 80 or more. So also 3. So 3 students. And this time we can use both graphs. So both stem and leaf and the frequency distribution. How many students participated in the fundraiser? In other words, they sold tickets. So I could count up the leaves here and I get 15. I can also look at the cumulative frequency of 15. So it's 15 students. And I can write both. You probably have a little more room than me. So I'm going to try to squeeze this in here, write both. Okay, now when I ask the other questions, you're going to have to refer to your paper because you're not going to see my chart anymore. So, number 8, what is the mode of the tickets sold? So, in other words, which one appeared the most often? Hopefully, when you look at your stem and leaf plot, you can tell 66 appeared twice. So, 66. And we can only tell stem and leaf. We can't tell from a frequency distribution exact numbers, okay? And since 66 is the mode, that's an exact number, we can't tell by the frequency distribution. Okay, what is the median number of tickets sold? So median is the middle number. So I'm going to come back up to the stem and leaf plot here, and we're going to cross out 1 from each end. So lowest, highest, lowest, highest. Do this with me. Lowest, highest, lowest, highest, lowest, highest, lowest, highest, lowest, highest, and that leaves 1 in the middle. And we know there's going to be a 1 in the middle, one number in the middle because I have an odd number of data. And so this would be read, I have a stem of 6 and a leaf of 9, so that would be 69. So write 69, and since I was looking for an exact number here, I can't use the frequency distribution, so I'm going to write SNL plot. Okay, now the mean. Mean is the average, so I have to add them up and divide by how many. So if you look at the stem and leaf plot, I have 40, 51, 55. So I've already added that up for you, and it adds up to 1,022. And I divide by 15 because that's how many numbers were in the data. And my calculator, we're going to round to the nearest tenth, so my calculator said 68 and 1300, so I'm going to underline the tens place and look to the right. If it's 5 or above, I give it a shove. If it's not, I'm going to let it go, so 68.1. So circle this. This is my mean, or average, and I'm going to write SNL plot. Okay, let's look at the last page. So it says line plot. Line plot provides an ordered display of all values in a data set and shows the spread of data on a number line. It can be used to quickly identify the range, the mode, and any extreme data values. Okay, so use the line plot to create a frequency distribution that shows the height of 7th grade students. So we have to come up with a title here, so we're going to use height of 7th graders. So height of 7th graders. Okay, now I'm going to move down here so we can see the line plot and the frequency distribution at the same time. All right. So what we have to do is look at the interval of 51 to 55. And then tell the frequency. Now to read a line plot, all you do is there's 152, 155, 156, 3, 4, 5, 6 seventh graders that have a height of 57 inches, 4 that have a height of 58, 5 that have a 59, and so on and so forth. So the first interval is 51 to 55, so we're going to look in this spot here, 51 to 55, so I see 2 x's, so the frequency is 2. Cumulative frequency is all together, so far I have a cumulative frequency of 2. Now we're going to block off 56 to 60, and I'm going to count up all of these x's. And when I count these up, I get 18. And so the cumulative frequency would be 20. Because it was 2, 18 more makes it 20. 61 to 65, so I'm going to look at this area right here, 2, 4, 6. So the cumulative frequency is 26. 20 and 6 is 26. And then finally 66 to 70, and notice my graph ends at 68. So, but that's okay, it doesn't have to end at 70, there just aren't any students with heights of 69 or 70, so it just stopped at 68. So 1, 2, 3, and the cumulative frequency would be 29. So there are 29 x's here, which represents 29 heights of 7th graders. Okay, so how many students are between 56 and 65 inches tall? So I can count all the x's from 56 to 65, or I can also look up here, 56 to 65, I see 18 plus 6 is 24 students. So I could actually use both to come up with that answer. How many students are 61 inches or taller? So this interval is 61 or taller, and so is this interval. So what's 6 plus 3? 9 students. Okay, which interval is the median height located in? So to find the interval that has the median height, I actually have to find the median. So I'm going to cross out 1x from each end until I end up with 1 or 2 in the middle. Now I know I'm going to end up with 1 in the middle because I have an odd number of data. I have 29 data sets, or 29 numbers represented on my line plot. So cross out 1x from each end. And we're going through here, crossing out 1 from each end, 1, 1. And I see that 59 is in the middle, so the median is 59. So the interval that would contain the median would be 56 to 60. We'll write that in a minute. But if I know there's 29 sets of data, and I know half of 29 is about 14.5, so I'm looking for about the 14th, 15th number in the middle. I know it's going to fall in here because 2 plus 8 is 20. I know there's 20 data sets here. I know the 15th number is going to fall in here. So I could also look at a frequency distribution to find where the median interval is. I can't use the frequency distribution to find the exact median, but I can use it to find the interval. And I can also use a line plot to find the interval as well. So let's come down here. The interval is 56 to 60. And then the last question, how many students are 55 inches or shorter? You can look at your frequency table, or since you can't see it on my screen, we can just count 55 inches or shorter. Now remember, 55 or shorter, 1, 2. So 2 students. Okay, that concludes our notes on frequency distribution. I hope you have a great day.